Every chance I got. And I've been putting it on my iPad and listening just to the code, trying to make sure I know all the definitions so that those hopefully will go faster during my test, and then trying to work with the tables too.
Did you actually get a chance to go through all of the, what happened to my, there we go, there. Did you actually get a chance to go through the homework assignments?
The ones we did while we were there, I did do them. The ones that we did afterwards, I have not done all of them.
Okay. Do you have any questions that I can answer for you before we get started with anything in particular?
Let me see. I had one that I was looking at. Let's see.
I'm gonna.
Let's get started, and I'll ask it somewhere. I'll figure it out.
Okay. Well, out of the class, all the stuff that we covered, what part of the class, or what part of the stuff that we covered did you not, or is there anything in particular that you just didn't really feel like you got enough of in the class that you want me to explain to you? Or
Man, while we're at the class, it's all clicking, 100%.
Yeah.
But I get on my own, and but last night I started looking at the book some more, and I'm trying to get down all the tabs, get familiar with them as I can. I have been for some time now, and I feel pretty good about it. I mean, I don't know everything. I know I'm probably going to barely skip by, but I think I'm going to barely skip by.
Did you took it already once, right, or no?
No, I have not taken the test at all once.
Okay, all right. So, really for the Journeyman, the biggest, there's just not that much math on that test. Bottom line is that if you can't navigate quickly through the code book, you'll be at a disadvantage. That's really going to be the hardest thing for you tomorrow. And that being said, the time management part of the stuff is really critical. I mean, you really, the stuff I was telling you about, going through the whole test, I mean, looking at every question before you even open your code book, and just try to knock out any of them that you know. And it may be that you only know 3 of them, right? Okay. I mean, I totally get that. It won't be 3. It'll probably be 12 that you'll know. That's about what average is. But, the object isn't really for you to just pick out the 12 that you get right. The object is for you to be able to kind of sort and organize the exam, and be able to consolidate questions that are similar to each other, be able to kind of consolidate chapters and questions that kind of relate to the same area of the code book, and also to kind of separate those questions into piles. Ones that you know for sure, ones that you have a pretty good idea of what they are, a good guess at, and the rest, which will be math, prints, stuff you don't have any idea what they're asking you, that kind of stuff. And I'm not trying to tell you, I want you to bog yourself down with a lot of, analyzing this stuff. I mean, if you don't know it, just skip it. You know what I mean?
Yeah.
But the beauty of the whole thing is, and I'm telling you, I do this with every exam I take, because it's always nice to go back at the end of that test and then be able to go look at particular groups or piles of questions. And so what I'll do is I'll sort them all into those 3 piles. And when I get to the very last one, I'll answer it or skip it or whatever I'm going to do with it. And then I'll actually go to the go-to button at the top of the screen. It's at the very top corner, at the very top line on the screen. And then I'll select the unanswered block to go to next, because those are the ones that I'm going to spend, a lot of time in. And that's when I'm going to start opening the code book. But I've got a general idea of how many of them I'm faced with grounding and bonding, how many of them are on. So for example, that practice Journeyman exam you had, there were, I think, 5 questions on that test that all came off at 250.122.
Yes.
And so if you're doing a run through and you see those things, kind of run through your radar, they're not questions that you necessarily are worried about. You probably won't. I mean, that table, I don't have it memorized. I mean, it's a lot of lines on that table. So, I mean, it's okay to skip those, but you're kind of cataloging them in your mind, how many of them you've seen so far on the test. That way, when you go back to that unanswered block, the first one of those questions that you come across again the next time, you'll go to that table, and then you can just skim through. Every time you hit the next button, it just takes you to the next unanswered one, and just keep hitting next until you find the next one that is on that table. And I'll do all the questions that are on a particular table if I know there's more than one question, and there will be some tables that are like that. And so I'll just kind of winnow it down just like that. And if you have 40, 50 questions that aren't answered after that first run through, that you haven't either marked or answered, I'd be surprised. So
yeah. Okay.
Anyway, so that's that. The second part that's really important to you is going to be on a Journeyman's test, because of the fact that you're just so content laden with code type of questions. That table of contents for the chapter 3 stuff will save your life when it comes to bending radiuses and strapping rules and things like that.
Okay. And I guess the other things that I had found a little more difficult to remember from class is conduit fill and the box fill and figuring out how many square inches of box I need for every tube that's in there.
So conduit fill, and what was the other?
And then like
box fill?
Not necessarily, box fill, but also how big a box do I need when I have two number 2 conduits coming up from the bottom and 4 number 4s going out the back.
Yeah, you're talking about junction box sizing.
Yes, sir.
Okay. Do you know the difference between a junction box sizing and a box fill question, or what the difference in the trade between a box and a junction box is?
The difference between a junction box and a what box?
And just a box. Junction. Sorry.
I guess junction is where everything's coming together.
The difference between these two is that this right here, box fill, when we're talking about just smaller, 1900 boxes or 4 square boxes or 411/16, things of that nature, they have a maximum wire size permitted to be put into them of a number 6.
Okay.
So typically, if you had a question that had some number 4s in it or something of that nature, then junction boxes take up after the box fills taper off. So anything that's size 4 or larger, sorry, it's number 6, right. 4 or larger is going to be a junction box.
Going to be a junction box.
Yeah.
Okay.
Not that has anything to do with anything. It's just an interesting piece of that, I think, that helps me kind of keep it straight. But anyway.
Can for sure keep your questions
separated.
Keep you from looking under box fill for anything that's over number 4.
Right.
Need to look there. Look somewhere else.
All right, so let's look at conduit fill real quick, okay? Conduit fill is one that you'll probably have maybe 2 questions on your test that have to do with conduit fill, so you'll definitely have some, but I don't know that they're certainly not 4 or 5 of them by any means. With conduit fill, we're in chapter 9. Chapter 9 starts, and I don't have a code book with me, so you're just going to have to bear with me. But chapter 9 starts on page 756 with some notes to it in table 1 and table 2 at the bottom of the page on the left-hand side of the opening there. So there's some significant tables in chapter 9 that are important to you. And of the 5 that are, important to you, table number 1, which is on page 756, is that right?
Yes.
Okay, at the very top, which is your conduit fill allowable percentages, right? You don't really, it's kind of an explanatory table that kind of helps you remember what, the number of conductors in a conduit would be X percentage, but there's only 3 numbers on it, so it's not a hard one to memorize or get used to. But the one that's at the bottom of that same page, which is table number 2, I'm going to just kind of give you some notes to put next to that are not related to necessarily conduit fill, but that is basically a one-shot shoe bender table. However, everywhere in Chapter 3 that you have any flexible conduit, they tell you to use that table that you're looking at the bottom of the page. So any kind of flexible conduit, doesn't matter whether it's plastic or metal, FMC, ENT, doesn't matter, flexible conduit.
Okay.
They tell you to use the very, very last column as the maximum bending radius, minimum bending radius for that conductor or that raceway tile.
Okay.
So, for example, if they gave us just say a 3/4 inch inner diameter. No, FMC is done on the outer diameter. 3/4 inch FMC. What would be your minimum bending radius according to that table?
5 inches.
5 inches. So that's how you use that table. And so you just want to put a note to yourself down there that all flexible conduits use this table for minimum bending radius. Sorry, I'm trying to get used to this tablet here.
Okay.
But you can see it okay, right?
Yeah.
Is it large enough you can see what I'm writing?
Yes.
Okay. Radius, radii. What's plural of radius? Radii.
Let's see what, I guess, yeah.
Radiuses.
Radiuses.
Okay, so that kind of gives us some housekeeping, right? So those 2 tables there, they're important to you, but they're not critical. The 2 that you see that are on the next couple of pages, so starting on page 757 is table 4. And table 4 is all of your raceway types, right?
Yes.
So, for example, EMT, practically speaking, there's only 2 columns on that table that we ever pay attention to. Last code edition, they had it backwards, and so they made it a little bit more user-friendly in this edition. So since we normally use 40% conduit fill on a regular basis because we normally have more than 2 wires in a conduit, right?
Yes.
So that 40% then is normally what we would use, which is the first column that you're looking at, and you're going to look at it under the inches squared column.
Yes.
So if I had a 3-inch EMT, and this is definitely inner diameter, what would be the maximum percentage of, or the maximum area of inches square that would be allowed to fill 40% wise?
3.538.
All right. Okay, so then we've got, let's just say 250 kc mil feeders that we're bringing into. Oh, by the way, what happened with your air conditioning branch circuit wires? Did you make him go back and replace any of those?
No, I hadn't yet. He's been out with a hurt back, so I hadn't got to talk to him yet. But
I was curious. XHHW will call them. So the second significant table that you'll see back there is table 5. And table 5, I can't remember what page it starts on. It's about 2 or 3 pages back from 7.
6. So we're doing 250 case meal XHHW.
Yeah, XHHW is actually the very last page of the table 5. Now there's also another table in there that's table 5A. That's completely separate from what I'm talking about. So table 5 ends on page 765, I think.
4.
Oh,
Yeah, 765 is 5A.
Okay. So on page 764, then, do you see XHHW on that line item on the far, or the beginning left-hand column there on the page?
Yes, it'll be 2.3. No, I mean
And, all right, and with this table, you got to be using the middle column.
Be 0.3904.
0.3904. I'll tell you, really, Justin, the thing you have to be careful with on table 5 in particular, is you just have to make absolutely sure that the insulation type that you're being asked to size is actually on that row that you're pulling those numbers out of, right? Because they're all kind of intermixed in there, like THW and THHW and THWN and THHN, they're all kind of mixed and matched. And sometimes they'll even skip some sizes. So they have a block of smaller ones of one insulation type, and then they'll change to a whole different insulation type, and then they'll pick back up where they left off, on the next page. So you just have to be careful that you make sure you get the right line. But 0.3904 would be the correct number we'd be using. So these two numbers then, this 3904, and again, that decimal point's really important right there. And this maximum allowable percentage of fill of 40% of that 3-inch EMT, those are the two numbers that we'd have to make sense of a conduit fill calculation.
Okay.
And if I want to know how many 250 casing mills I could fit in that, I would just take this number and divide it by this number.
Okay.
Which would be what? I don't have a calculator. I do right here, actually.
That was another question I had. Do I need to take my calculator, or do they?
No, they have a desk full of them.
Okay.
Yeah.
They probably won't even let you take your calculator, right?
They're supposed to allow you to, but I mean, I've gotten so lazy lately. I just use theirs. I mean, theirs are really simple, and they're usually new, and so I've never had any trouble using theirs. But be sure, and if they don't give you one, be sure and remind them that you need one. So 3.538 divided by 0.3904. So the maximum allowable percentage of the conduit means we could put 9.6 of those in that raceway. Is that what you got?
You put 9 of them in there. Yeah.
Now I'll tell you that example we just did right there, where we're dividing the wire size into the raceway size, right?
Uh-huh.
This is where note 7 comes into play, and note 7 was that special note that told us that
0.8 we round up.
Yep.
Anything up 0.8 and anything below 0.8 we round down.
Yep, 80%. 80% of that wire has to be in the allowable fill area for us to be able to calculate that as another wire. So only 20% of that wire, that last wire, can be in the no-fly zone and still be able to count it as a whole nother wire.
Yes. Okay.
There's really, I mean, I just, they'll give you a conduit or a raceway type just like this, PVC or FMC or something of that nature, and then they'll give you how many conductors of whatever particular type can you fit in it, which is similar to what we just did. Or they may give you a list of wire types and wire sizes and ask you what appropriate size raceway would you need to match up with those. You just work it backwards. On this latter example, you just start in table 5 and just pull out each one of those wires one at a time, and then just extend it out times however many there are. And that's probably, I mean, there's nothing complicated about it. You just got to remember to just kind of don't forget any wires. I mean, if there's 4 of them, make sure you multiply that individual value times 4. I know that sounds kind of silly to mention, but sometimes that happens.
Yeah. Okay.
Table 8, which is on page 767.
Okay.
Is that page 767?
766.
I've been one page off. All right. So this page has got a bunch of things going for it. Basically, for you, the most important stuff is the circular mill, which is what the American wire gauge is converted to do any kind of mathematical calculations with a wire size, because a number 8 doesn't mathematically do anything for you because it's just an arbitrary label, right?
Yes.
So to convert a number 8, if I had to do any kind of math with a wire size, I'd have to convert that to a circular mill area, and I think that's 16,510, right?
Yes, 16,510.
For number 8?
Yes.
All right, and so you'll also notice that you've got 2 rows there next to the number 8, and kind of about 3 or 4 columns over on the right, you'll see where it says 1 and then a 7 right below it on the second row.
Yes, like the quantity.
Yeah, I think it says quantity.
Uh-huh.
You see there's 2 rows of number 8, right?
Yes.
And on the top of the top row will say 1, and then the bottom row will say 7. That's just a solid single strand, and this would be a stranded conductor. So there's 7 strands in a number 8 stranded conductor.
Okay.
So if you ever have to do any solid versus stranded, that's what those 2 rows are for.
Okay, and that's the difference in square inches. That's the difference in .013 and .017 is one of them stranded.
Yeah, they still have the same exact circular mill area because that's the quantity of mathematical measurement units that a number 8 represents, right?
Okay.
It's just that the size, as far as conduit fill and things of that nature, with stranded conductors, it's going to be a little bit larger. Maybe not noticeably, but it is larger than a solid just because you've got some space between the strands. So.
Here. Okay.
And that's really, I just wanted to make sure you understood. You'll notice that is that way on all the smaller conductors all the way up to, I think, a number 8's that stops after that and goes to just one line after number 6, right? Or is number 6 got 2 lines on it?
No, number 6 has 7, 7, 7, and then it's all
right. So those stranded certainly. All right.
It's the biggest single strand you can get.
And then you'll notice that after you get down to 250 kc mil, it just says 250 on the far left-hand column, and then it's blank under the circular mill column because that is 250,000 circular mill.
AC mill.
Yeah.
Already the circular mills.
Old school guys would call it MCM, and I still think MCM makes more sense than kc mill, but that's
okay.
Same difference. 1,000 circular mills.
Okay.
And then I think that's probably all you'll need to know about that table. I think it's worth just kind of being aware of it. And ask the question that comes off of that table. All right. Box fill. Do you remember what article box fill's on? Or what table that is?
Let's see. For box fill, there is 314.
314.6 A and B.
Yes.
I'd be lying to you if I told you what page it was. Don't tell me. 179?
186.
Golly, man, I'm way off. 314. What'd you say, 6 or 16?
314.16.
What happened to my A and B? So you have 16A, which is the larger table on the top.
Yes.
That's all of your standard box sizes. It's the middle set of columns there that say minimum volume allowance, and then it's got inches cubed listed there. So that is the standard manufacturer's measurement of space inside that box. And then the table at the bottom, which is the B table, is a count per wire size in inches square or cubed. So for every wire that I've got that's number 10, for example, I'd have to actually calculate 2.5 cubic inches.
That's number 10 would be 2.5, yes.
So I'm telling you, these used to be some of the more complicated calculations in the whole code book, but lately they've kind of backed off on them, and now they'll just give you 6 number 10 conductors, 10 number 6 conductors, and ask you what size 411/16 box would you need for those. And I'm asking you what the size would be.
10 equals 50. So 65 inches. And then
65? Is that much?
6 number 10s is 10 times 2.5.
Yeah, it'd be 25, yeah. Yeah, you're right. No, I'm sorry. No. That's what I was thinking you're trying to do to me. Let me get this. It's not And this is what they do to you. Okay, this is a great example. It's not 10 number 10s, it's 6 number 10s.
Okay, 6 number 10s. So,
So 6 times 2.5.
2.5 is 15.
Okay.
And then 10 times 5 is 50. So it's 65. No, yeah, 65.
50, 65. Yeah. No, you're right. Sorry. Yeah, exactly right. When you went back and said that, I think I misunderstood you maybe.
So I need 65
That'd be way too big.
cubic inches. That'd be, yeah.
Yeah, was it 40
off the chart?
The biggest? 42 the biggest 40 box?
Let's see, 4 squared is 42. Yeah.
So, but that's all that I've seen lately on these exams as far as box fill goes. So, I mean, as long as you know those two tables, where they're at and how to use them, you'll be fine.
Okay.
A couple of other tables that I promise you, let me just write a couple of these tables down. 110.28. 300.5. I skipped two really important ones, which is 250.66 and 250.122. You'll also, and I'm going to go back and give you another one that I'm 110.26A1. So those 5 tables right there, I would almost promise you those will be on your test.
Okay.
And this one is hard for a lot of guys to remember where it's at. It is the enclosure type, like the 3R or the 4X, so on and so forth. Do you remember that table?
Yes, it's on page 43.
Okay, and remember on that table on page 43, the X marks the spot, so that's a good thing.
And it's the enclosure types: rain type, snow,
Yep.
whatever you have to decide, whatever scenario they're talking about, probably what type of enclosure you need.
Right. And then if you'll flip back a couple of pages to 110.26A1 real quick. So this is a working clearance table. So for example, let me clear this off. So if we had a wall here, let me redraw it here. So we had a wall here, and we had a 480 volt panel, 3-phase 480 volt. The separation between this panel, right, and whatever would be immediately across or directly facing it on this wall right here, if it was kind of a short room there. Let's say we had a transformer right here that was also 480 volt rated. So this table is laid out between 0 and 150 volts, and that number, Justin, is the per leg voltage class.
Okay.
So a 208 volt panel would actually be on that top row, not on the second row.
Okay.
And I tell you, for a long time, I didn't understand that, and I used that table wrong for years and never really stopped to read it carefully. But it's 0 to 150 volts. That's leg to ground or phase to ground reading voltages. So we're talking about a 208 volt system or a 240 volt system. Both of those would actually be in this row right here.
Okay.
Because we're really only talking about 120 volt to ground is the number there. And then you have 151 through 600, or is it 1,000?
Through 600.
And that is basically 480 volt panels or 277 volt panels, if that's, if they tried to give you that voltage class, which I I don't think I've ever seen them do that, but they possibly could. Those would be in the second row. Anything on this stuff right here is 3 feet. Doesn't matter what this wall right here is, or whether it's insulated to ground or not, it's 3 feet.
It's all 3 feet anyway.
Yeah. But this row is different. And so it's 3 feet, then you've got 3.5 feet, and then you've got 4 feet. And leave it to, you know, PSI to give it to you in inches. So they'll give you 36, 42, and 48 instead of just leaving it alone and making it easier to read. But they'll probably give you the answers in inches. Just be aware of that.
Okay.
So if I had this setup right here, I had these 480-volt panels and transformers like this across from each other, then the distance between the live energized parts of these two pieces of equipment would have to be one of these 3 numbers here based on what this wall right there is made out of. So condition number 1 is a insulated wall, basically, where it wouldn't, you know, potentially allow you to ground yourself to it on accident and get yourself, the risk of shock is less. So it's still 3 feet in that case if it's ungrounded. But if it's grounded, and specifically they'll label it, I think they even say tile, ceramic, glass, something like that in there, bottom of the table. Condition number 2.
Yeah, concrete, brick, tile, and walls shall be considered as grounded.
Yep. And then that would be 42 inches. And then if you have exposed live parts like I've got drawn right here, then that's condition number 3, and it's really not about the wall any longer. Now it's about
Live parts.
That's right.
So
So
it
we
goes,
would have, if we did them directly apart from each other like this, we'd have to have at least 48 inches of separation. Whether those have enclosures or dead fronts on them, I mean, it doesn't matter. At one point, they'd be exposed, so we count that as condition number 3.
okay,
If it's a 120-volt panel, it'd be 3 feet.
be 3 feet.
208, 240-volt. Okay, the other 2 tables, 250.66, you'll have a question that asks you the size of basically a service ground or GEC. And it's on page 121 of your code book.
Yes, GECs.
And it's real simple. It's just based off the largest ungrounded service conductors. So if they give you 2-aught aluminum conductors, you would be on the second column there. And I don't have that table memorized, so I think it's about the 3rd line maybe.
So be number 2.
Now, if they gave you the feeder in aluminum, you'd probably still answer in copper unless they specifically also asked for aluminum. But
So it would be, so if they gave you aluminum as the feeder, 2-aught, it would be 6 copper grounding.
yeah, if they gave us 250 kc mil aluminum, right? But then they didn't specify what material type they wanted the GEC sized as. You would assume copper.
Copper.
So they'd have to basically tell you here that this is also aluminum.
Okay.
Otherwise, what in the heck, Algic? Anyway, it's real simple table. It's not really complicated. And the other one that you will see a lot more frequently on your test is 250.122. That's the one on page 131. This is an EGC table. And I think you may have some notes on there. That's basically a branch.
Yes, a branch ground.
It has to have a breaker in front of that wire. And if it does, then it's an EGC. So that's basically how you keep them straight. If there's a breaker listed in that question, the wire size does not matter. It's always the breaker size that sets these grounds.
Okay.
So you just, for example, if we had a 60 amp breaker, right?
Uh-huh.
We'd size that as number 10, and that actually says that. I think that's the 3rd row there.
Yes.
But a 70 amp breaker, which isn't actually on the table,
We'd have to go up to a number 8.
yep, you automatically are on the next row all the way down.
Okay.
And if you have parallel sets, there's no discount. And what I mean by that is if they were to give you, let's just say you had 3 sets of parallel feeders, and they were all being fed by the same breaker, right?
Okay.
So let's say I had 1,000 amp breaker.
You'd have to have a 2-aught ground.
Yep, and I'd have a 2-aught in every one of those, because I have to clear that whole entire fault current with just one wire.
Okay.
So we size full size in each one.
In each one.
Yep. No discounts. That's the way I always remember. When it comes to equipment grounding conductor, there's no derating the wires or trying to break it into smaller pieces.
Because even though you're breaking up your voltage going to whatever, to clear that ground fault, you have to have that 2-aught wire to handle that.
Yep. If somebody were to cut through the other 2 legs or the other 2 parallel sets, you want that last one to be able to clear the whole fault.
Okay. Otherwise, you might not get enough going back to ground for the breaker.
Right. Okay, and then 300.5 is the other one that I promise you'll have on your test. Page 149. Is that right?
149.
No.
No.
Dang it, 179? No.
Top 5 is 145.
What? Your code book's got some wrong page numbers or something. Couldn't be me forgetting them. All right, so this is a table we talked about in class. It's not a complicated one. You just got to make sure that that top row where it says all locations not specified below. If they give you anything crazy sounding in a test question that doesn't match on any of those rows, that top row is your default row.
Where are you going to go to?
Yeah. And so it really does have to be real specific otherwise. And then the first row, you have UF cable listed on the top of that one because that's a direct buried type cable. So UF cable would fall under the first column. I said rows, excuse me, column. And then the second one is PVC.
Rigid metal?
Okay, rigid. And then the third one is PVC.
Yes.
And then the fourth one is the one that's got the 20 amp GFCI residential requirements. So you got to have all 3 of those. And then the fifth one is for basically low lighting.
Okay. Yeah, I think that table is pretty. I mean, it's pretty self-explanatory. You're going to go under
So
ground. That's how you're going to go.
Let me see if I can ask you real quick. Let me get this thing out of the way here. So if you had a question that had to do with ranges, right?
Okay.
Let's say you had a range of sizes 5,000 watts. And they also had another range sized as, excuse me, just messed my drawing up, sized as 3,500 watts. And they ask you for the volt amps, minimum volt amps required for the service.
You got 5,000 watts and 3,500 watts. Let's see, where ranges, there's a table for them, aren't there?
So what the first step is, you're going to look at what column do these fall under, right?
Yes.
Is this a column A or B on the 5,000?
So this is going to be on the 5,000. It's going to be a B, column B.
It is. And the second one?
The second one, doesn't it fall in? Don't you just do them all under column B if the one?
No, you got to look at them individually.
Individually,
Unless column C is involved.
It falls under column B also.
It does, yeah. So since they're both on the same column, we look on row 2, which is 65%.
Uh-huh.
And you would multiply those 2 times 0.65.
3,500 plus. So it'd be 5,525.
Yeah. And if you have a column A and a column B, you just do each one of them under their own respective column times however many there are of each one of them. All right, if I had a range sized as 16 kW, single range, let's just call it, what would be my demand load for that range?
16 kW, it would be 80%.
Yeah, this is 16,000, right? It's not 1,600, it should be
16,000. 16,000. Okay.
Yep.
You're doing
that puts you in column C.
that puts me over into column C, and it would be 8,000. Correct? One range.
That to start, that's right. So remember, the way I always do it on scratch piece of paper is I'll write it just like this, 16,000 watts.
Okay.
And right below that, I'll write myself a note that that's 12,000 watts is what column C is good for. And what it shows you right there on row 1 of column C is 8,000 watts, right?
Mm-hmm.
And that's what you were telling me. That's what you meant.
Uh-huh.
Now, we still, though, unfortunately, we have to deal with all of the differences between these two.
Between the 12,000. That's right. Okay.
That's right.
So,
And
yeah.
so each one of those 1,000-watt steps is going to end up being a 400-watt hit.
So it's 8,000 plus 400, which would be 8, 9, 10, 11, 12,000 watts. Is that right?
Well, it'd be four steps times 4. It'd be 1,600, I think, right?
So it's 4. So each 1,000 watts is
400 watts.
400 watts. So it would be.
Basically, yeah, just look at the 4. This doesn't really matter too. So it'd be just.
So it's 1,600 watts.
That's right.
See, when we went to class before, for some reason I've got down here 8,000 watts and then 1 kW plus 400.
Okay, and that's what I mean by that. Let me redraw this and make this a little more clear, because it does. I mean, it can be pretty simple. Let's say we had 16,000.
Uh-huh.
So I'm going to subtract the 12, which is what column C is good for. So I'm just trying to keep my math straight. So this is what column C is rated for as a maximum value. And on row 1 under column C, you're looking at 8,000 watts, right?
Okay.
So this is my base calculation right here. And then I just look at how many steps did I go past that 12 kW, how many steps they go off the chart. In this case, I went over 4 separate steps. That's the difference between what the column is good for max and what size I actually have. And each one of those steps is 400 watts. So what that note that you have there is 1 kW
Uh-huh.
equals 400 watts. Because 4 times 400 is 4 of these at 400 watts each. You know, that's what I was trying to say. So for every kW you go off the chart stops at 12,000. So every 1,000 watts you go off the chart, you're tacking on another 400 watts.
Okay.
Yeah, I wasn't even going to bring up ranges because I'd rather you just, it would take us a good hour to go over ranges, I'm telling you. Oh my gosh, I just hope you don't have too many of them on the test tomorrow. Do you feel comfortable with that table, or do you understand it at all?
Yeah, I'm pretty comfortable with it, especially if they stay down in the lower ones, and then that one, that clears up what I was about the bigger ones. If it's over a certain amount of over 12,000, then you have to add 400 per thousand after that.
Right.
Right. Okay.
Yes, sir.
And then on dryers, I've got that little sticker on dryers.
Yeah.
So it's just 1 dryer is 100%, 2 dryers are 100%. But then I've got a minimum 5,000 watts per dryer.
That's right.
So if they give me 10 dryers, I'm going to go 10 times 5,000, and that's what I have to size. That's for feeder sizing, correct?
That's right. But the percentage that you're looking at on that table would be multiplied against that number. So if you had 10 dryers, right? So what you said?
Then if I had 10 dryers, it would be 50%.
Yep. So you do 10 times 5,000 watts for each dryer, and then that number times 50%, and that'd be the number you'd keep.
Okay. So the 5,000 is the minimum watts per dryer.
Yep.
Then the percentage rate on my table is the D rating.
Yep.
For however many there are.
Yeah, and I don't see too many dryer calculations on the Journeyman's exam. So you as long as you know that 5,000 watts, you'll probably run across maybe one reference to it in the test. But the more complicated dryer questions are usually on the masters. So.
Okay.
All right, and motors is one of those things that we covered that pretty good in class. Did you feel pretty good about those?
Pretty good about them. Yes, sir.
Okay. Pretty good?
Pretty good.
So let me ask you then, just real quick, and I'm sorry, I got to kind of wrap it up because I got a big test tomorrow, and I'm sorry, I've been kind of dragging tonight. But if I had a 5 horsepower motor, and I'm sizing the wire, let's say that was a single phase. That's an S, not a 5. Single phase, 5 horsepower. We'll call it a 120 volt motor. What size wire, and what would be the steps that we'd use to size the wire?
I think I've got to go to my motor horsepower table first.
Yep.
Correct. And where is motors at? It is.
Page.
Here we go. 430 motors.
Mm-hmm.
And so let's see. No, not that one. Limitation. No.
Use that table of contents. Go to the very front of your book because you have some notes to yourself with page numbers.
Motors, feeder taps. Okay, here's 330.
At the very bottom of the page, don't you have some single phase, 3-phase FLC at page 350 and 351?
Yes, AC, FLC.
Yep.
350 to 351.
Yep. And so page 350 would be where you'd be headed to get the FLA value for that motor.
Okay, so I want it's a 3-phase.
Single, I'm sorry, that's a single phase, not a 3-phase.
5 horsepower motor, and it's 120 volts. So it's going to be 56. What is that? 56 going to be? It's a 56 amps, right?
Mm-hmm. Is that what it says on the table?
Yes.
So on page 350, on the very first column there, so 5 horsepower, it says 56 amps. And I think that sounds about right.
Yeah.
I mean, it would have to be at 120 volts. That's a monster 120 volts. So I get that. Now what do we do for wire?
Okay, so we're at 56 amps. And then we have to multiply that by 1.25.
Oh, you're a beautiful man. I'm so proud of you. That's exactly right.
And so we got 70 amps. And so then we go to the table on wire size. On 161.
Yep.
And go that we need 70 amps, and our, 75-degree column is going to be for motors.
Yep.
And we're going to go to 85 amps, and we're going to have to go to number 4 wire.
Yep. You just missed the number 6 by 5 amps.
Yep.
And that's exactly the way you do it.
Okay.
That wasn't too hard.
Now, one question I had for you, and this has nothing to do with the test, but like a lot of our motors have they have overcurrent protection in them. Does that qualify for the same overcurrent device that like you would like a heater?
Yeah, like in the central heating unit up in the attic, right?
Huh?
There's usually like 2 circuit breakers in there.
Yes.
Those are the ones like for the heat strips.
Yeah, there's some for the heat strips, but then like the motors are internally overload protected.
Well, so those breakers aren't overloads though. Those would be over current, like short circuit ground, but they might be for the motor. I mean, one of them's probably for the blower, isn't it?
Yes. Uh-huh.
Okay. All right. So your question is it the same as what you have out in the panel on the outside? And the answer to that's probably not, because typically you've just got one breaker that feeds that branch circuit. And then once you get to the unit, then the unit will use that branch circuit in various split fashion, I guess.
Yeah.
I don't know how they internally break it down once it gets into that unit, but that's a manufacturer's deal. Does that answer your question, or am I even on the right track?
No, like if I pick up a regular PSC motor and I look on it, it'll say overload protected.
Okay.
Is that internal overload the same as, like you're saying, if you have a big old haunchy motor, you'll put a heater on that motor that
Yes.
motor in the wire?
Yes.
That qualifies the same thing as that heater, right?
Absolutely. You're absolutely right. Yep.
Because basically if that motor overheats, it's going to shut itself off.
That's right. Absolutely. And then it should, after it cools down, it should reset itself. Some of them you have to manually do it. Some of them do it automatically.
Okay.
Yeah.
And I was just those smaller motors, if that was the same. I mean, I know it's the same concept, but is that the same concept as far as electrical code?
Yeah, so the smaller motors that are less than a horsepower, right, like your garbage disposals and stuff like that, those have them in the windings of the motor itself. They're just, I mean, I've taken them apart before back in my days, and you'll see a little, kind of bent over piece of. Yeah,
it's basically a clicks on.
Yeah, and then there's a button on the bottom to reset it or something, but.
Mm-hmm.
But anything, though, that's 1 horsepower or larger is required to have a separate overload that's not intricately located in the equipment.
Okay.
But your air conditioning equipment's a different animal, and there are some special rules when it comes to overloads, and I'm almost positive they allow that to be part of the manufacturer's deal, because you don't normally put overloads on separate overloads on air conditioning equipment anyway. So if it's not done, I guess internally, I don't know how you give it protection.
Okay. All right. Well, man, I think I hope I can pass it.
All right. So don't forget, like I said, when you first sit down in that chair, there's going to be that 15 minutes or whatever, that little pre-test. Just use that time for yourself. Go over the prints. Spend a little bit of time, basically once they give you your seat, right? So you go in there, check in, they take your picture, you give them your ID, and then they give you a set of prints, a boogie board, which is your little note-taking deal, and then they'll tell you what seat number to go sit in, right? Once you go sit inside there, then you're supposed to enter your Social Security number onto the screen and hit enter. And once you do that, then you've got this little 15-minute block of time that you're supposed to be doing this practice exam or whatever, but just don't even enter your Social Security number until you're ready to get started. And spend a little bit of time, relax, get those prints out, go through them till you're at least know what's on them. You know what I mean? Okay. And then once you've kind of got your wits together and you've kind of got yourself settled in, then you can just click through all those answers on that little pretest that they don't matter to you. They're just there to help you get comfortable with your system. And then when you get started on the test, leave that code book closed, go through the whole test. Like I said, and you either know it and you answer it, or you think you know it, and those you would answer. And then at the top, there's a mark button, and you just mark the ones that you're kind of iffy about. Okay. And anything else, just skip it. But just kind of mentally be keeping track of how many Article 250 questions there are and how many motor questions there are, so that you can kind of deal with them in block units as you go through them later on. Okay. And then once that last test question, that 85th question comes up and you hit next, it'll say, do you want to end your exam? And you say no. And then you go back to the go-to button, or just go back to a different question number and then hit the go-to button at the top of the screen and then choose the unanswered block. It'll be a little pop-up window that's got 4 little items to pick from, and you just click on the unanswered block, and that'll take you to the first one that you didn't answer. And then when you're in that view screen and hit next, all you see is the ones that you didn't answer, just the ones you skipped. Okay. And then when you've gone through all of those, and that'll take you probably 3 hours, I'm guessing, Usually guys take about 40 minutes to go through the exam, the first run through. And then when you go into that first block of unanswered questions, that'd probably be 3 hours worth of your time. So that's 4 hours right there. I mean, you've only got about 25 minutes left after that, I think. So you want to leave yourself enough time to do the mark questions, is my point.
Okay.
All right. Well,
All right.
You're testing at what time?
I'm testing at 10 our time.
Okay. Well, text me and let me know one way or the other as soon as you get out, would you?
I sure will.
All right. Thanks, sir. Good luck.
Thank you.
All right. Good night.
Hope you do good on yours too.
Thanks. I appreciate that. Talk to you soon.